Hey guys, very good afternoon. So first of all, thank you everyone for joining this session on this Sunday afternoon. So I hope your weekend is going great so far. So we have a really interesting masterclass on exploratory data analysis today, and fortunately we have Hardik Gupta as the guest speaker today, who is a lead data scientist at Misho currently. Previously, he was working with Mobile Premier League and Book My Show. So he's a really experienced professional with more than 8, 9 years of experience in this domain. So please join me in welcoming Hardik Gupta. So Hardik, very good afternoon and looking forward to the session from you.
Hey, thank you, Vikas, and good afternoon, everyone. Thank you for that warm welcome.
All right, so I think Hardik, you can please go ahead and take over and just on the other side of the session. All right.
Sure. So just give me a second. Maybe I can start sharing my screen. Let me just set up a couple of things here. All right, I think just give me a moment. Just give me a moment, guys. 1 second. I'll share my screen. Cool. I think we are good to get started. So I think we are around a healthy number of participants. So welcome everyone. Welcome to our learning journey. And today I think we are going to talk about a topic which is sits at the heart of be it a data scientist or a data analyst position. So we're going to talk a little bit about what is called as exploratory data analysis. And while we talk about that, we'll actually get started about where does this entire piece really sit in the heart of the entire ecosystem. Okay, so the course of our entire journey today is going to go like this. We'll get started about what is data science and slight bit about where does data analysis really sit into picture, how EDA will help business achieve making their decision making, life cycle of data science, and some of the popular tools which can help us do this kind of data analysis. And to do this, what we're going to do is we are going to do a role play here. So we are going to assume ourselves as a data analyst working at Uber. I hope everyone has used Uber or at least know about how Uber works. And there are some couple of questions which the Uber management would love to explore. Something simple, however, core to their business, because if you are able to figure out some of the answers from what the data is going to offer to you, it will be really good for the management, because everything in the end, we make decisions that results into some kind of revenue improvement for the company. Okay. I think there was some initial plan to work with IMDb dataset. Firstly, apologies for that. Realized that there was some kind of issues working with that dataset, and hence we have right now switched over to the Uber dataset. However, whatever concepts that really we want to cover still remains the same. So none of that would have made a difference. In the end, it's all about we need to get analytically tuned so that whenever a data set is given to you, what kind of pieces is that what you can work with. Okay, so apologies for that. Okay, before we go and get started with this entire piece of data analysis and everything, let me just give you a very short thing about what is this data science and data analysis, data analysts, and all those things. Okay, see, you talk about DS, which is data scientist. What is their major role that they do? Be it data analyst also. So everything which I'm going to talk about with respect to data science here applies to both kind of roles. So it's not very specific only to data science or data analyst. You can think of it as a very generic thing. We are those kind of people who ultimately are making decisions using data. Okay. So we make decisions using data. What is data? Think of data as nothing but information. Okay. So it is this data which will help us to analyze, after an analysis, interpretation, some amount of inference, modeling, will help us reach a stage where we can make the decision using data. How this will help any company? So think of like this, that today, if I am able to make certain decisions using the information which I have, it can ultimately impact your company in getting better and better revenues. For example, if you are able to understand that if there is something which improves a new source of income for a company or even an existing one, that's directly impacting with the revenues of the company. On the other hand, some other kinds of companies can have better user engagement. Okay, so you might end up understanding the pattern in the data sets, which can help you understand some kind of user engagement as well. Okay, so decisions which are nothing but based upon informations have these kind of outcomes which are directly impacting your revenues or user engagements. And think of yourself as a role which will involve a lot of analysis, interpretation, inference, and modeling. To do this, Python is one of the tools that we use. But ultimately, as a data scientist or as a data analyst, your job role in the end is to make decisions using data. Okay. So why data? Is because data is all about information. So I really want to, you to know about this piece in detail. So what is data analysis? From a theoretical angle, it's nothing but a process of examining, cleaning, transforming, and modeling data to extract meaningful insights and information. So whenever you will be doing data analysis, it will involve some kind of statistical techniques and tools, which will help you to understand what kind of patterns are there, if there are any relationships, trends in the data set, things like that. Okay. And the ultimate goal of any data analysis is to help individuals and organizations make those informed decisions, converting the raw data into useful kind of information. Okay. So I think there's a very funny meme here, which different perspective of what people think of data analyst. This is also not completely right. We just don't do Rubik cubes. There's a lot of things which we do in the end. So that's what it is. Okay. Now, let's see here a little bit something more in detail, that how does this EDA, okay, which is nothing but think of it as a synonym of whatever data analysis that I've been talking about, an appropriate, or say some kind of official lingual word which the data science community uses, is what is called as exploratory data analysis. Okay, so this EDA, which involves a lot of things, we'll speak a little bit about it in just some time. They will help you to make better decisions using what? So they will help you identifying trends. So let me show you an example when I say identifying trends. So here I have the money control page of Asian Paints, and I want you to look at this graph and tell me, what do you see? What kind of a trend do you see? So if very quickly, I think I can even share a Padlet link, which can, help my class to be more communicative instead of just being a one-way monologue. Uh, because I think I can directly share this link in the chat box, right?
Yeah, sure.
Okay, so I can share this link, and yeah, maybe if we can probably start speaking a little here. If I show you this kind of a trend here, what do you think? What kind of a trend do you see? higher high, higher lows, flag and pole, upward trend. Okay. So negatively skewed chart. Okay. I think a lot of people are using some technical words, but okay. What is the first impression that you get to see when you look at this kind of a trend? Maybe we can have some answers here. Up to 2022 increasing and then after decreasing. Uh, yeah, maybe I can feel the pain in that voice. So let's invest in Asian Paints. Of course, it's an expensive stock. You should, but definitely try about. But come on, guys. I think okay, maybe we can use a chat box only here. But yes, you're correct. So a lot of people are thinking about the same lines that Hardik, I see an upward trend. We'll not talk about Adani groups because that's a wrong trend and something which I don't want to quote about. But clearly, if I look at it from a very longer horizon here, I see a trend which I see that's something to move in a upward direction. Okay, so as the time period increased, I saw that this particular stock has really done well. And of course, there is volatility, there are these ups and downs, but on a longer horizon is something which I see that, hey, there is an increasing trend. So now help me understand one thing. If you would have understood this piece of trend, right? What you could have done, of course, as an individual, you would have been interested. So say, for example, if you were around 2019, right, or 2020 kind of a setup like this, you would have stood here and you would have looked at the last 5 years of data and what kind of a trend it shows, right? So of course, as someone is pointing out, paisa hi paisa hota hai. Of course, yes. So you can see, if I was standing somewhere in maybe 4 years ago from now, I was around what, 1300 rupees, and exactly in 4 years, paisa double, right? So it's not an Anuradha chit fund. It's pure something which has given a lot of value, right? So of course, what I want to now highlight here is that if I was aware of this kind of a trend, as an individual, I would have invested in that kind of a company. As an advisor, I would have advised multiple people to make certain kind of better decisions. So you see, when we do EDA, okay, now you would say, Hardik, this was just single plot. Okay, you just drew a trend chart. But exactly, that's part of our EDA. I took the data, and not just data, I have probably summarized the data at a monthly level. So you see, I've looked at the data at a monthly level, one month kind of a data. And I'm now looking at it for a longer horizon, which has resulted into me some kind of a decision here. What kind of a decision? Please invest in Asian Paints. Okay, this is not my advice, but what the data is also suggesting. So that's one part of uh, EDA's benefit to business, to an individual, that it helps you to identify trends. What kind of other trends also that you can talk about here? So say, for example, say you are Swiggy. Okay, so imagine you are Swiggy. So you know that Swiggy has identified, and I am Hardik. So Hardik Gupta on every Friday between 8 p.m. to 10 p.m. would end up ordering some kind of a pizza costing of around like maybe 400 to 500 rupees. Okay. So basically, this is a characteristic of an individual. Okay. What has Swiggy done? Now, Swiggy has identified this kind of a pattern, or also say this kind of a trend for me, and what it will do. So they know that, hey, Hardik, around maybe like weekend. So maybe sometimes it could be Friday, sometimes it could be Saturday, sometimes it could be Sunday, somewhere around weekend, between say a time period of so and so, would have ordered an item, maybe pizza or somewhat related to it, of a particular amount. Okay. So now you tell me, if you were Swiggy and you identified this kind of a pattern from my behavior, what kind of things you can do? I would really love to know what kind of things you can do. Auto order, brilliant, Ravi Kumar. So someone is saying auto order. Okay. Offer suggestions, Yash, very good answer. He is saying that you could have now given me offers, but now think of like this. I would be counter that if I know for sure that he's going to order, is there really a need to give me a discount? Right? There is no need for me to give a discount, right? So probably I can stop, in fact, giving you a discount. On the contrary, I know for sure Hardik Gupta will transact during that kind of a period. I should not really give him a discount. Price hike is something, again, would be controversial. But yes, the least thing which I can do is maybe not give discount. Pushing notifications, yes, another very good answer. So if you see that by around 9 p.m. or 9:30, you don't see an order, or you don't even see that Hardik Gupta has not even opened the app, what you should do, you can send him a notification that, boss, it's weekend, party night, right? Like, where are you? Are you alive, dead? So these kind of things. So exactly, that's another example of identifying trends. ED also helps us a lot in identifying outliers, right? So for example, if I show you, if I have to draw a salary chart, okay, if I have to draw a salary chart of all Indians. So let's say this is a salary chart. So what I'm going to draw is just like some kind of a histogram. So for peeps who don't know what is a histogram, think of it as a frequency plot. Okay, so it's frequency plot. So if I were to draw the salary chart of the frequency plot of every Indian, I would have maybe got something like this. Okay, so this is like my x-axis. Pardon me for my drawing. This is my density or the count of people. So x-axis would be, so this is like 5K. This is probably like around maybe 20K. This is say around 1 CR. This is 500 CR. And this is 50,000 CR. Okay, so this is 50,000 CR. So who is here? Probably, people who are below the poverty line, who are here on Aam Aadmi, right? Like common janta. So people like here between 20K to 50K, 1 lakh. This is Aam people, common man. Who is 1 crore here? Someone who works at maybe a management consulting company or some kind of that individual. Who is here? Here is Amitabh Bachchan, right? So here is Amitabh Bachchan, 500 crore in a year, or just one season of Kaun Banega Crorepati. And who is here? Here is Ambani, correct? So now, if you look at it from the entire chart, what do you see here? So you will see that people like Ambani and Amitabh Bachchan probably are sitting towards the very right end of this entire chart. So if I were to calculate that the mean or the average, I should say, salary of all my Indians, if I do using all of this data, would turn out to be maybe somewhere here. Okay. Say it turns out to be maybe, I'm just saying maybe 2 lakhs. But do you think from the chart that really this is this average salary of all the Indians? No, right? So there are certain points, certain data individuals, which are really pushing your analysis away. Okay. So this is where EDA will really help us to do. Okay. EDA will help us answer these kind of questions with a lot of conviction that, hey, your analysis via some visual analysis or some kind of statistical summary, you would be taking a better informed decision at the end. Okay. So these are small questions. Probably we are starting on a lighter note. Okay. But I hope you're getting the point that why everything here is working with respect to data. Okay. So no intuition, no operational related things which I'm doing. Everything I'm using data. Data could have outliers. I am analyzing those outliers. So now these outliers also could be of 2 types. Okay. These outliers also could be of 2 types. It could be a noisy data set, or it could be a noisy data point, or it could be some kind of a influential data point. Now you might ask me, Hardik, what is noise? Say, for example, if I ask you what is your age, and you give me your answer as my age is minus 56. So we know that for a fact that minus 56 is something which cannot be a valid age. Of course, this will be an outlier, something which will not follow the common pattern. And what will be an influential data point? Ambani is an influential data point. Okay, is he a noisy data set? Of course not. He's not a noisy data set. Okay. What about relationships? Okay. So for example, let's see if I have to show you a meme. So identifying patterns, identifying relationships, people can start to recommend you these things like customers who bought this also bought this, right? Have you heard this kind of a statement somewhere? I mean, this is just jokingly a very sad meme, but you get the point, right? Like, of course, no one is going to sell you just one piece of shoes. So what you will end up seeing is a lot of this kind of setup, like customers who went to buy this, will also buy like this, right? So how do you think someone like Amazon or Netflix, right, has really gamed the system that, hey, you know what, you went to buy a banana, but in addition to that, maybe I can even recommend you a carrot, right? And you might agree to it that, hey, you know what, indeed, this is the thing which I also wanted. So what I have understood is that by analyzing this kind of data, pure play data analysis can also give you an answer, or it can set you as a benchmark for you to do further analysis when you go towards model building as well. So the point is, when you do a good amount of EDA, these kind of correlations, these kind of relationships, which might be present in your data, even without building a model, it can help you do this kind of a thing. So you can just say like, hey, when I went to buy a banana, what is the most frequent item which was also bought along with the banana, right? So that's a very low hanging answer to your question that, hey, it would make sense that if I just start to probably recommend in an online setup, or even in a brick and a mortar kind of a setup, to keep these items next to each other, right? So this might really improve your ultimate revenues as well. Of course, it will help you to improve your data quality. So it will help you to identify and address any errors, inconsistency. I did speak about the negative values of the age and the influential points like Ambani. So that's really, really helpful when we go towards the data analysis, right? And of course, it helps us ultimately all of these things to make some good decisions. So uncovering patterns, trends, relationships in the data will firstly help you to, solve a lot of business problems in the end. I'll take a pause here to check if everyone is aligned with me up to this point. Folks, all good? Yeah. Anyone has any questions? Probably we can take a small pause here. Share my collab link. I think Vikas has already done that. Okay. Any questions anyone has? I'll just take this. Sure. Okay, now let's move towards the core piece where Hardik, in the data science project, as a data scientist or as a data analyst, where does this entire piece really sit? Okay, so let me very quickly touch upon the life cycle of data science. So whenever we are given a problem, right? So whenever you will be given a problem, you should always ask this thing to yourself, that the first thing as part of the life cycle of any data science project is define the problem statement very well. Define the problem statement very well. Why so, Hardik? Is because this is the make and break of your entire project. See, try to understand one thing. You are a DS and your job involves making decisions using data. A lot of times, problems can be solved without data as well. For example, a problem could be solved using because of marketing issue, or it could be an operation issue. We really don't know, right? So unless and until we know for a fact that yes, it's a data problem, defining the problem statement very well would be the right thing to do. The next thing which you will do is, probably I'll go to here. Yeah, the next thing which you will do is data collection. Okay, so now that this is the place where you will go and understand that, okay, I need to solve a kind of a problem. I have refined the problem statement very well. I know what I'm going to build. Now I need the data to collect. Now this kind of a data collection activity itself could be a project. Okay, so sometimes data collection might not be an easy activity. You could not have data, and data collection could be an expensive, or it could be a longer duration process. So this in itself could be a project, but the point which I'm trying to drive is you will have to identify those data sources from which you can collect the data. Now, once you have the data available to you, okay, please remember one simple rule of any data science project, which I call it as GIGO. What is GIGO? Garbage in, garbage out. Okay, which means, see, data science is a box to which if you feed GIGO, which means if you feed garbage, do not expect magic. Okay, so we are not magicians. We are not living in Hogwarts. We are no Harry Potter peeps. If you feed garbage, and you will get garbage out. Okay, so once upon a time, a very famous person quoted few things, right? यहाँ से आलू डालो and यहाँ से सोना निकलेगा. No, that doesn't that doesn't work in data science. So always remember one thing, that for us to really make use of our data and the decisions on top of that, we really need to understand that whether the data has been cleaned and not. Okay, so this entire process of data cleaning, preparing the data, and doing the analysis on top of that, together you can think of bubbles 3 and 4 is what we give it as a higher term as EDA. Okay, so exploratory data analysis is nothing about the entire step of data cleaning, data preparing, and then asking a lot of questions to the data to understand what the data is. And that is why I feel whenever we do EDA, right, for me EDA is all about dating the data. Okay, it's all about dating the data. What is dating means? Like I'm pretty sure a lot of us know we go on dates with the opposite gender, right? Like, so when we go on dates with the opposite gender, like what do? It's an attempt to know the person, right? Know the person. So we are trying to build a relationship with the opposite person, right? So we go, we ask questions, we appreciate the person, that hey, how beautiful do you look, how beautiful do you talk, you have such good credentials and all those things, right? Like ultimately what are we doing? We are trying to know about the person, right? We are exploring the person, right? So that we can make a decision that, boss, do we need to continue or we do not really need to continue, right? So I consider EDA as going on dates with data. Unfortunately, we are geeky people. Poor data scientists don't go on dates with humans. We go on dates with data. Okay, where instead of knowing the person, we try to know the data, and we ask that, what is your distribution looking like? Okay, what is your distribution looking like? Do you have any noise in your data set? Okay, how much are you skewed in your real life, right? So we ask these kind of questions, and you won't believe, like, asking these kind of questions in the end helps us to know that how bad is your data set, what all things do we need to worry about when we are ultimately going to talk about probably modeling in the later stages. Okay, so spending a lot of time by doing EDA, which means that asking a lot of questions to your data, starting with simple things of cleaning the data set, preparing the data set, building a relationship with the data, is what we intend to do in our EDA exercise. Okay, so in a you might see a typical meme also a lot of times that, Hardik, I am a data scientist or a data analyst. Okay, they are not giving me the job of modeling. But think of like this, right? That your most important job, if you ask me, so you define the problem statement, collect the data, and then you do this EDA, right? Where you're building the relationship, know more and more about the data itself, right? This is where the entire meat of the entire problem statement really lies. Okay, so the success or failure of any data science project really lies in this meat where we perform EDA. I'll be honest with you, okay, that it is not something that I can really teach you in one class. No one can teach you EDA. EDA in the end is nothing but it's an art. Okay, how do you get better and better on this art? Practice. So the more and more data sets that we come across, the more and more we see that how problem statements are getting solved, I will start to tinker your analytical thinking that, hey, okay, when you are given a data set, what are some of the things that you can do? However, having said that, whenever we are doing EDA, I know for a fact that there is some kind of a template that we can at least follow. Okay, so it's like a plain canvas. You are an artist, okay, and you'll be drawing a beautiful picture in the end, but you go as and when your analysis continues. Okay, so you do an analysis, you will get some output. You will see, you will further do more analysis, get an output. You will see, you will do certain further more analysis, get an output, and that's how the entire flow is going to work with. Okay, so I hope people are all following up to me with this point. Now, once you have that EDA done, you date the data and everything piece done, you go towards your model building, which would be again an iterative process. So you build a model, check the accuracy, go again, build the model, check the accuracy. While you're doing this thing, you're iteratively becoming better and better in your model. Ultimately, you feel satisfied that yes, this is a piece of code that I can go and deploy. You go the deployment, perform an A/B experiment, see the results, and then continue the entire cycle again and again. Okay, maybe I'll take a pause here. I hope this flowchart is understood by everyone. Any questions, guys, in this piece? How is ML used in EDA? Yeah. So basically, ML will follow EDA. Okay, which means that once I have the problem statement defined, I collected the data. The data could be noisy. There could be a lot of garbage in my data. So if I feed garbage to my model, do I expect any beautiful results out of it? No, right? So think of EDA, which is nothing but a combination of data cleaning, data analysis, data preparation, and then asking some of these questions are going to prepare yourself to feed that kind of a data to model building. So model building. So what is model building? I maybe if I have to quickly just touch upon this entire piece of model, right? What is model, guys? Think of it as some kind of maths, which is encoding a pattern in the data. Okay, it's some kind of mathematics which is encoding this kind of a pattern in the data set. This is what is model it is. Hardik, how do you know this? Okay, for example, say if I draw a chart like this, okay, and I stop here. Say if I draw a line here, I call this as my past data and I call this as my future. It's a very simple example. Now, if I ask you, where do you think after this statement, after this point, will it go in direction A, B, C, or D? In which direction do you think it will go? It'll go in A. Okay, so a lot of you are saying it will go in A. Why so? Why so? Is because you have looked at the past data, encoded this kind of a pattern that if you give me a value of X and apply a sign function on top of it, you will get your Y. Correct? What is this sign function? Think of it as your model. It's a very simple model right now, but it's a model. It's a piece of maths which has encoded your pattern in the historical data. It has encoded into some kind of an equation for now. Real life is not so simple. That's why we have a very complicated looking functions. Sometimes we don't even understand what's happening inside the function, right? So what has happened now that in future, if you give me this kind of an X, I will give to my model, this is my model, and I'll work on top of that. Okay. So I hope this makes sense that when you speak of model, right? Model is nothing fancy. It's nothing but maths in the end. That's why I don't know, for peeps who are already aware of how linear regression works, it's nothing but an equation, right? What is an equation of the line? Y is equals to mx plus c. Okay, this is nothing but a line equation. So you give me an input, you get an output. Okay, this is nothing but a model for me in the end, right? Okay, cool. So let's move ahead and let's speak a little bit about some of the popular tools that you can come across when you're working with analytics. Again, none of this is something which is it totally depends upon the company that you work with. So it's very difficult to say that, Hardik, will you be only end up using Python? Will you end up using only SQL or SAS? No. So depending upon project, depending upon your company, you would end up using any of these tools. So what are some of the popular tools people use in analytics? First one is Python. No introductions required. It's a high level programming language, extremely versatile when it comes to doing prototyping, building a production grade code, deploying in the production system, interacting with a lot of systems, a huge community available for its support. So there's a lot of benefits that when it comes to working with Python. SQL, it's a query language. So when you have data in a structured format in something called as a relational databases, it helps you to retrieve the data and do some kind of an analysis on top of that. Now, between the two, if you ask me, between Python and SQL, Hardik, which one should you learn? You should learn both. Python has just one added more advantage on top of that. It's just that it will also help you to do modeling. So the model piece, which I just showed you. So analysis, interpretation, inference, and modeling. Okay, these are the four pieces that any data scientist or data analyst has to do it, right? In the end, modeling is something which the other three SQL will also do it. Modeling is something which SQL cannot do it. So Python also ends up doing that. So people prefer a lot of Python. Microsoft Excel. So this is our grandfather before even the Python was born. This has the veteran who helped us to do the four pieces: analysis, modeling, inference, interpretation, everything. People used to do it in Excel. Unfortunately, the data size has grown a lot. People need a lot of flexibility to connect with a lot of other systems and work in a very real time kind of setups. So that's where people have moved away from Excel and gone towards these kind of Python languages, or more like a programming language. Python is just one of them. There are a couple of them as well. Tableau, think of Tableau, Power BI as tools which will help you to do beautiful dashboarding. What I say dashboarding, beautiful visualizations. So one part of making decisions can also come from visualizing graphs. Okay, what do you mean by that, Hardik? What I mean is that you can look at graphs which are nothing but information encoded in a graphical format, and that can help you infer some things about it. Okay, so it's not about aesthetics. It's not something that I have made a beautiful graph, but it's all about creating informative pieces. Okay, so Tableau and Power BI both again are paid tools, however extremely strong and very popular in the community of business intelligence, and a lot of people use it on a day-to-day basis for building these kind of dashboardings and really beautiful dashboards, right? And visualizations in the end. So the intent is to analyze the data and then visualize it. You can even share it with a lot of stakeholders. Your stakeholders could be people who are from business teams, your strategy teams, your CEO. He can just look at the dashboard and make a lot of informed decisions that he wants to make for the company. SaaS, on the other hand, is again, it's a suite of tools. Think of like this. Again, a very paid software kind of a setup, extremely used in financial domain. So a lot of finance people, you will see, still end up using SaaS. So a lot of these things which I spoke about, analysis, modeling, inference, interpretation, which all the other tools were doing, SaaS is like a combination of them, and it's like its own ecosystem. So SaaS will have its own modeling piece as well. It will have its own what do you say, visualization piece as well. It will have its own analysis piece as well. People end up doing a lot of SaaS what do you say, certification. So SaaS minor and all those things, very expensive certification. So people do, and they become a SaaS certified data scientist or a SaaS certified data analyst. So there's a full certification stream for working with SaaS kind of products. Yeah, so there's a question someone has asked, like, what about R? Yeah, R is also actually a good language. Unfortunately, it did not is as famous as Python. I started my career in R, to be honest. I still love R. R and R Studio are, if you ask me honestly, one of the very beautiful language to do my data analysis. However, Python, just because it has a lot of versatility, as I was speaking, when it comes to deploying in production, interacting with a lot of other systems and everything, and a huge community and support which is available, Python beats it hands down. So you see a lot of deep learning development also getting done at a very good rate in Python language, but not as much as in R. So again, learning R, absolutely nothing wrong in it. It's just that you will have to start learning Python also at some point of time in your life as you move in your career. Okay, some of the other product and core analytics stacks, like things like there is Google Analytics, Mixpanel. Again, these are more from analytics perspective. There's Amplitude, Hotjar, Microsoft Clarity. So think of like this, from a Tableau from a tool perspective, there are a lot of these softwares which are available, or tools which are available. In the end, even if you end up learning one or two, learning the others is not something which is fancy. Okay, so it's not that you will have to start everything from scratch again. Things are quite relatable. So learning one or two, probably like something like Google Analytics and Mixpanel, is something that can really get started. So it's a product analytics platform that will help business understand how users are interacting with their products. I think there is this Clever Tap as well. I think, yeah, one of the, it's used in a lot of recommendations and data collections and those kind of activities. And Google Analytics is again like a full web analytics service which is present. Okay, maybe I'll take a small pause here to check if we are doing good. Any questions anyone has? A lot of people I see have raised their hands. I don't know if I can unmute them. Kunal, by any chance, are you answering these questions? Okay, there are a few questions. What is an outlier? I think we explained. How can we get into cricket analyst position? Oh, that's a good question. If you see opening at ESPN or Star Sports, probably just apply. There's anything fancy apart from this. So yeah. What is my favorite tool to do EDA? Python. Like for me, it has been always Python. Okay. How deployments of models to be done? Yeah, Tushar, probably this is a question for some other time. Might not be the focus for this class. What is the job of data analyst and job of data scientist in life cycle? Yeah. So you see, Aman, probably a data scientist would end up doing all of it, and data analyst would probably end up doing these three steps a little more. Okay, so business analysts, a lot of stakeholders would do the first step with you. You will also be a part of it. It's not that you'll be alien to it. You'll go help people with data collection, data cleaning, EDA. And it's just that modeling is something which you might not end up doing, modeling and deployment. So that's where you will take helps of data scientists, and for deployment, you can probably take helps of data engineering. But yeah, like different roles, company to company, the boundary again is not something which is so well defined. You might also end up doing the modeling pieces or even some kind of deployment pieces, right? So that's the thing. Okay. Cool. I think let's get started now with my case study that I have. So I have a small case study. What we'll do is, so we're going to talk about the Uber case study, where I hope everyone is aware of Uber. So what's Uber? It's basically a ride sharing service which allows people to use cabs on demand. Okay. And it's a market with a lot of changes in demand based on factors like time, place, weather, events, right? So you ask yourself, 31st December, 12 o'clock, 12:30 a.m. in the morning, in the night, you try to book an Uber and God bless you for that, right? So it's a very dynamic kind of a system where depending upon the time and the place where you are standing, the demand or the supply could really vary, right? So 8 o'clock again in the morning in a city like Bombay, you demand for Uber versus 9 o'clock, God bless you again. So again, it's a very dynamic kind of a business. The key to success in ride sharing is to be able to understand how demand changes and provides rides when people need them. So think of like this, if you are a management of Uber, right? What you would like to do, you would want to understand that how my demand is shaping up, when is my demand shaping up, and if I can know these answers upfront, that hey, I know for a fact that at 8 o'clock in the morning, if there is a spike in my traffic, probably I would want to incentivize my drivers to come at that point of time, right? Very simple things you might say, but extremely useful. Now imagine that you are not using data. On a hunch basis, you will understand that, hey, in my city, 8 o'clock is something where people really go out. But it could be that it's not 8 o'clock, but 7 o'clock or maybe 9 o'clock, right? So, of course, you would say that the difference is not that much, but when you actually go on the ground, things might be really very different. Okay. So, looking at the data, that how the pattern of these pickups and rides have happened can really give us some gold mine answers to a lot of questions that the company has. So our objective right now would be that we are trying to, as a data analyst, we have been given the task of extracting some insights from the data that will help the growth of the business. Okay, so things like the Uber management is asking you questions like, what are the variables that influence the number of pickups? So what factors affect the number of pickups the most? What could be the possible reasons for that? And what are your recommendations to the Uber management to capitalize on fluctuating demand? So how you can really see that if demand is fluctuating so much, how you can really work with it. So we'll try to see some of these things in our analysis right now. Okay. So what we have in our data, we have this open source data set where I have data collected about different Uber rides across New York City. So I don't know how many of you are aware, but think of New York City as like, just like any other city, but divided into different zones. Okay, so they have different zones, right? So they have this zone, that zone, have different zones. I think they have limited zones, but yeah, it's different zones. They call it as boroughs. Yeah, I think someone also pointed out islands, I think, yes, but they are called as boroughs. Okay, so there is Manhattan somewhere, and there is yeah, I think there are a lot of other these kind of borough places. So there's Brooklyn, there's Manhattan, there's Queens, and all those things. So there are a couple of things like that. So what I have done here right now, I have these Uber rides which was done in the New York City across the different boroughs, and I have also collected the data that across the different hours, what was the weather condition also at the same time. So if you look at it, what I have in the end, so this is a data set that I have the pickup time, which is the date and time of the pickup, where in which borough, how many pickups happened. So you can think of it as it's an hourly data set. So at 8 o'clock in the morning, which means between 8 to 9 in this particular New York zone, I ended up having so many pickups done. At this particular hour, which was for this particular 1 hour, the wind speed defined by the variable SPD was so and so, defined in miles per hour. Visibility was whatever it was. Temperature in Fahrenheit, dew point, sea level pressure, 1 hour liquid precipitation, 6 hour liquid precipitation, 24-hour liquid precipitation, snow depth in inches, and whether it was a holiday or not. Okay, so this is basically the traffic data set itself, but aggregated at one particular level, hourly level. Otherwise, it would have become individual traffic. That's also something that you can analyze. But for right now, to keep things a little under control, otherwise, you can imagine that in 1 hour, a company like Uber in a city like New York might have received so much of traffic. So crunching that data or preparing the data collection itself would have been another masterclass in its own sense. So for now, I have this kind of some kind of a summary. Now, one thing which I want to tell you guys right now, for people particularly who are from non-coding background, or have not so great exposure to data analysis, data science right now, there are certain pieces of codes which I'm going to run. Do not be worried. Okay, so think of like this right now as an idea that if you were asked these kind of questions and given this kind of a data set, what kind of procedure you could have followed. Okay, so think of it as a small snippet right now, which would have done over a couple of days time. And this is something which you can also learn. So just to give a disclaimer to a lot of people who are new to this kind of field, don't get really overwhelmed that I didn't understand a particular piece of code. Try to understand the thinking behind my analysis here. Okay, so that's the major takeaway I want you to have from this analysis. Before we go ahead, I want to set this kind of a disclaimer so that you and me are on the same page here. I hope that makes sense, guys. So can I see some thumbs ups here, or any other one? Any has questions? I think there are a lot of questions. One, this thing, request, guys, that if you have your questions answered, can you just get them removed from this Q&A? That will really help me understand that I'm able to answer as many questions as I can. A lot of people in this webinar, so yeah, I am not really sure if these questions are answered. So is there any certification? Not okay. After completing deep learning model, are we able to do some masterclass complete? Okay, I think these are not some relevant questions right now, so probably I think we can move ahead. Awesome. Okay, let's go and see. What I've done right now is, since I'm working with Python, I need to import certain libraries. Think of these libraries as nothing but some kind of modules, some kind of packages, something simple as code, which will help me do my analysis. Please always remember this thing. Your job as a data scientist or as a data analysis ultimately is to collect decisions using data. Okay, you want to make decisions using data. What is data? Data is information. Your job in the end is to analyze, interpret, infer, and model the data. Okay, your job is not to become a Python developer. That's a very different, separate role. Okay, so in the end, even if you will, become not so great at coding, that's still acceptable. Okay, but what's more important is that you need to think in the right direction. So here what I have is some kind of libraries imported, couple of important libraries that I'm using. So I'm using NumPy and Pandas, which are going to help me to do a lot of analysis, and Matplotlib and Seaborn, which I'm going to use for my visualizations. So I have this uber data.csv stored. Okay, and I'm loading this into my data frame. So I'm reading via pandas and making this kind of a data frame here. So you can see when I did my data.head, I'm inspecting the top 5 rows of my data set. So what are my top 5 rows of my data set looking like? I have the pickup date for this particular date and timestamp in this particular borough, which was Bronx. So many pickups happened when the speed of the wind was so and so, visibility was so and so, temperature value was this, dew point was this, and you can probably see the other variables, and ultimately whether there was a holiday or not on that particular day. Okay, so if you quickly go and check in my overall data set, I am currently having some kind of 29,000 rows spread across 13 columns. Okay, yeah, this is nothing but to just print the your graphs in the same cell. Yeah, even if you don't do it, that's still perfectly fine. Yeah, I think you can just ignore it. Okay, any questions anyone has on the data set before I go ahead? Everyone understood what is the purpose of our class right now? Any questions on the data piece? So you can definitely have a look at more details. Any questions around the data piece here? So I hope that the objective that we want to do and the data that we have is clear to everyone. Do we need advanced Python or Python basics? Yeah, you can work with even Python basics here. So yeah, precipitation is nothing but something to do with rainfall, I guess. Yeah. Okay. What is the use of Seaborn? Yeah. So what is Seaborn? Seaborn is nothing but a library. Matplotlib is doing visualization. This is doing visualization Gen Z version. Okay. Gen Z means it's going to make it very beautiful and jazzy and very, very good looking. So think of like that. Okay. So it's like the next variant in your visualization. Our package of data analyst. Okay, let me go ahead now and I'll come back. So let's start dating the data here. Okay, so there are a couple of things which we always end up doing whenever we load a data set. So irrespective of whatever the data that you have, okay, we would always want to know what is the data looking like. So the first thing what we can do is we can print df.info. So what is df.info going to do? df.info says that, hey, you have a data frame object which has a total of 29,000 rows. There are total of 13 columns which are looking like this. Columns are indexed from 0 to 12. Column number 0 is called pickup date. There are 29101 not null rows present in my data set, and it is of the data type called object. What is object? Think of it as string kind of data. Okay. Similarly, the next column which I have is called borough. It has index number 1, and I see there are 26058 rows. So now this should ring a bell in your head. Hardik, in total, I have 29101 rows. However, for borough, I only have 26,000 rows, which means what? That there are certain missing information in my data set. So that's the first thing which I get to know. And it's also of the type object. I think these two are fine. Then I look at the temperature. Again, temperature is something where we see that there is null present in my data set as well. So overall, I have these many columns. Okay, I have 9 columns belonging to the float type, 1 column belonging to integer, and 3 columns belonging to string types or object type. Overall, this data set is using around 3 MB of my RAM right now. Okay, so information completed. Now, usually it's always good to know the statistical summary for the numerical columns in my data set. So when I do df.describe, the next thing which I get to know is what is the distribution of my data set across the numerical columns looking like. What do we do here? So here we try to understand a lot of things. Firstly, what is the statistical summary of every column? Hardik, what do you mean by this? Here, I'm trying to understand, okay, you have total of 29,101 rows. The mean of the entire column is 490. You have the minimum value as 0. The maximum value is 7,883. The distribution across the different quantiles sitting at 25, 50, 75 looks like whatever the values are given. This entire report card, column by column, when I look, helps me understand the following things. One, what is the distribution of every column? In short, it's asking me, or it's telling me how skewed you are right now. Okay, so what is the skewness of every column looking like? Is there a possibility of an outlier present in the column? Do you see that there is good enough variation in my data set or in my column here? So when I look at this standard deviation column here, if you will agree with me that if this value is 0 or very, very close to 0, which means what? That this is a particular column which does not have variation. Think of like this, guys. Why is this important? Going back again, we are people who make decision using data. And for me, data is information. What do you mean by this, Hardik? Imagine for me to make my decision, if I give you a column called age, and I have in that age information like 20, 20, 20, 20, 20, 20. For all the rows, I have the information as 20. Okay. So what is the variation that you see here in data? What is the variation that you see in the data? 0, right? So now because there is no variation, do you think there is any information present in the data set? There is no information present in the data set as well. So it is very important to also, when we do a dot describe, that we look at this kind of standard deviations. It helps us to know that, hey, is it even worthy to work with that kind of a column or not? Okay. We of course do a lot of comparison when we say that I want to look at the distribution of my column with respect to mean and median. Okay. So I compare these two columns, how close these two values are to each other. Now, if I see that there is a lot of difference in these two columns, I am convinced that there is some kind of a skew in the data set. So Hardik, what happens when there is skew in the data set? Initially, not so much. Probably it's always good to know that how much is the skew present. It will also give you an information that there are definitely outliers which are present in your data set. Now, these outliers could be influential or it could be noisy. That's something that we'll have to further investigate. But then sometimes it also gives us information that because there is skew in the data set, there might be a chance, I have to remove the skew so that my ML models can fit better to data. May be required. I am emphasizing on the word may be required, that there is a chance that I have to remove the skew. So removal of the skew is a process, what we call it as data transformations. Okay, but we don't always start with data transformations. We always check first that with whatever skewness that you have, are you able to fit a model well? If not, it can improve the fit of the data, fit of the model by doing some kind of transformation. So probably You might have come across something like log transformation, which is very commonly used. So people end up transforming their data set, input data sets and everything, so that it starts to starts to follow or be more behave, which ultimately helps our ML models in the end to even better fit to the data. Again, I'm saying a disclaimer, we don't always do this. Okay, I'm nowhere saying that it is always required. We may or may not require. Okay, however, this dot describe in the EDA step told us that, boss, there is some kind of skewness in your data set. You might have to look into it. Okay, so this is more like I'm getting to know that, okay, this is some kind of noise which is present, and I might have to treat it, and I might have to work upon it. And you do this now for all the numerical columns. So this is like the first step which you start with, that I have numerical columns. Let me look at the statistical report card across each and every column in terms of these values which we see here. Okay, I'll take a pause here to check if there is any questions around dot describe. I hope this makes sense to everyone, guys. Yeah, any questions, anyone up to this point? Can't ML work on skew data set? Yes, yes, it can work. As I said, there might be a chance. Skew, basically, we were talking about this salary data set, right? I think there was this one graph, yeah, the Ambani chart which I showed, right? This is skewed. What is not skewed? So if I draw a not skewed graph, so maybe this is not skewed. Okay, it's like symmetric. Okay, yeah. What does a quartiles tell us? Yeah, so quartiles here would tell us that, you might have heard about these terms, that someone gave a CAT exam and his score was 99.9 percentile, and yet he didn't get a call from IIM ABC, whatever his dream college was, right? So what is this CAT 99 percentile? Is it something to do with his marks? Did he score 99.9 marks out of his exams? No, 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 no. What it means that if there were 100 people appearing for the CAT exam, okay, each one is a human, there were 100 people like this. Okay, each one got some kind of a score. We don't care about the absolute value. Okay, what do we say? That now I will sort these scores. And now this percentile is telling that if I am standing here at 99.9 percentile, there are 99.9% people who have scored lesser than me, and only 0.1% people have scored better than me. So 25th percentile is like only 25% people have scored lower than me, 75% people have scored better than me, right? So these are basically quantiles that we observe, and always good to know that what are these quantiles. It gives you some kind of a range of distribution. So in short, basically, one thing which I probably missed out also on mentioning is that when we do a dot describe and when we look at these quantiles and all, it talks a little bit about the spread of the data set. Okay, so how much is this data spread in your columns? Okay, so for people who are not able to understand coding right now, just don't really get bothered much. As I said, probably because you are new to your entire field of coding. For our today's class, just focus on how you can understand that what we are doing. Okay, so just try to absorb what we are trying to do. Okay, do not really get into the coding if you're completely new into it. In the interest of time, I might not be able to cover in depth about it, but yeah, just get a high level view that, okay, if you were to ask to do an analysis using Python, these are some of the things that you could have done. Okay, now this was good about numerical data set. Hardik, what about if you had categorical? So you see, calculating a mean value or a standard deviation on a categorical data set does not make really sense, right? So what do? We basically do just counting that, okay, if how many unique values are present in Burrow, what is the count of those unique values? So I have like around 6 values right now. So 1, 2, 3, 4, 5, 6. And I also see nan here. What is nan? Nan means not a number. Okay, so we'll come to that piece in some time. But I see that there are 6 unique values. Similarly, I go and analyze my holiday. So here I'm using value counts, which means what? That I'm looking at the distribution that in my entire data set, I have two unique values under the category of H day, which is holiday, whether it's a holiday or it's not a holiday. In 96% of my data, the value is no. In only 3.8%, my value is yes. Okay. Now you could argue, Hardeep, we could have done the similar thing for boroughs also. So let's do that here and quickly check what is the distribution across boroughs looking like. Okay. Yeah. So if I don't put normalize equal to true, or if I make it normalize equal to false, you will see that this will give you the count of number of rows which are having the value like Bronx. So in the column called borough, you have 6 unique values. The value like Bronx is present in 4,343 rows, 4,343 rows. If I do normalize equal to true, it will give me like a percentage distribution. So out of 100%, 96% rows are captured by the value n, and only 3.8% are captured by the value y. Similarly, here, if you see currently, I see it's equally distributed, right? 16.6%. So there is not much variation with respect to the borough column. I see that the data set is equally distributed with respect to borough. What else we can do rather than normalize? Yeah, I think this is the only thing you can do from a frequency plot perspective. Okay, cool. Sometimes it's also good to understand when we did this info, right? One of the important takeaways from .info is that looking at this data type here, okay, D type here, this gives you a lot of information that, hey, what is the type of data that you have? Okay, for example, imagine like this, you would have had a column like age again. Okay, now age is what? Age is what kind of a column? It's a numerical column. It's a numerical column. What do you mean by numerical? It means my age kind of a column maximum could have been like integer type, or it could have been a float type, right? Either of the two. But imagine if somehow age turns out to be a object type, which means like a super that it did not understand. So this should raise a concern for you. This should raise a concern that, boss, there is something wrong in the age column. I have to go and inspect, because automatically your pandas is smart enough to understand that what is a data type. Okay, so here imagine something like speed. It was able to correctly understand that it needs to be of the type float, right? So it was able to do it, but somehow imagine if this was not done. Okay, it was not there, it was object, then it's a worry sign. So we can see already one worry sign here in one column, one of the columns, which is pickup date. Pickup date was supposed to be a what type of object? Date time kind of an object. Okay, it's a proper date time kind of a setup. So it's not present there. So what we need to do? We need to go and standardize that kind of a data type here. So if I currently look at my top 5 values, so you see that this is something which is present in my data right now. Now, whenever we are working with date time kind of things in Python, there is a standard format for Python to work well with data types. Okay, so what is the standard format which Python expects your data time should be? It should be in the format of YYY hyphen MM hyphen DD, then hour, minutes, and seconds. Okay, so this is the format that it accepts, and this is what is called as a standard format. Currently, what is the format that you see? I think this is the format which is DD, MM, YYY, and then it is hour and minutes. Okay, so this is probably not the very best kind of a standard format. So what I'm going to do, I will use some kind of functions, some help to convert that column into a standard format. So I'm going to say, you, Mr. Pandas, use the function toDateTime, take my column. Currently, my column is in this kind of format that it starts with date, month, year, and hours and minutes. Please convert it into a standard kind of a format. So when I do this activity, look at the output that I got. I got YYY, MMDD, HH, minutes and seconds, hours, minutes, and seconds. So now this is a standard kind of a setup. And you will also notice that when I looked at this, look at the date type now. It is date time object. So now if you go and do a dot info on top of this, no longer your pickup date is of object type. It is of the date time kind of an object. Okay. So what is the benefit, Hardik? We can do a lot of benefits. For now, let's just look at the two, which is the start date and the end date that we have in our data set. So currently I am working with my data set, which is starting from 1st of January to I think 30th of June. I think I have some 6 months of data. And now, most importantly, you will understand that once you have a date time kind of an object given to you can do a lot of simple feature engineering on top of it. What is feature engineering? Think of it as deriving useful features from raw data, Okay. For example, if I give you this kind of a date time, what are some of the basic things that you can say? First of all, try to understand one thing. What is this column here? So if I have to quickly show you df.head, what is the column here? Let's try to understand the data set. It is saying that at this particular pickup date, in this particular borough, I got so many pickups. Okay. So it's a proper date time kind of an object. Now from this date time, what I can do, I can derive certain useful information. Features like what is the year of the pickup? What is the month of the pickup? What is the hour, day, weekday, so on and so forth like this. Now to do that, there are certain inbuilt operators in pandas. Okay, so what do you mean by this, Hardik? See, you could have argued with me that Hardik, even without converting into datetime kind of a thing, I could have still extracted from my original set whatever the features that you just mentioned. I completely agreed with you. There would have been some kind of a coding effort, but you could have managed to do that. However, when we are using and converting into datetime, look at this piece that I have done. So let me take this out and show you what it means. It says that in my data frame, this particular column is belonging to the type datetime. Now call a operator function called .dt. It is a standard operator. When you do this kind of an activity, when you write this kind of a code, it now gives you the access to call further functions which the datetime has to offer. So datetime has to offer what kind of things? I can extract the year, I can extract the month, I can extract the day. From this particular datetime, get me the year, the month name, the hour, the day of the week, things like that. Okay, so when I do this and I see my data set again, I have all those things added here. Okay, so I have the start year, the start month, the start hour, and yeah, the day, weekday, things like that. Okay, so I hope this makes sense to everyone. Yeah. Okay. Pretty simple stuff, but extremely useful. You will see that doing this kind of a data and doing this kind of what do you say, feature creation will help us a lot in making decisions. See, because if you look at the original data set, right, this is a proper timestamp. Okay, this is a proper timestamp. Just like how when I was explaining the Swiggy example, right? Imagine, like, I think today is Saturday, right? So I might order pizza, I don't know, but today is what, like 4th of February. It's 4th of February 2023 at 9 o'clock. Okay, it's a very exact kind of a timestamp. Now if Swiggy has to really extract any pattern out of me, right, what they will do, they will look at me on a weekly basis, that in which day of the week you were really more active, at what particular hour in that day of the week you were more active, and is it also towards the month end or towards at the start of the month, right? So we all know there's suffering which starts from the 24th of the month till the end, and how king kind of a feeling we feel during the first week of our any month, right? So they are very intelligent people to understand these kind of features, and that's how I want to understand that how my pickups have behaved during the different pieces of my timestamp. So timestamp, exactly, that's why I want to extract these things, and that will really help me to do that. Why during extracting month, like month name? Yeah, you could have even also done just month. That would have still worked with you. So if I just do month, let's see if I run this and show you very quickly. month series.month. This should have worked. Yeah, I think this would work. So, and if I run now, you will get the start month as, yeah, you can see here. Yeah, it has now been numeric. So this was just like a choice that I did. So I wanted the month name. That's why. Yeah, can we get the week of the year? Yeah, yeah. So now I think you should get the takeaway from here is that once you have that this kind of a setup done, right, there are multiple more functions which are available, multiple functions available. You can definitely go and explore. So there are more, I think, day name, even like you want the month also name and everything, all those things, day of the week. There are a lot of quarter related information is also present. So there are a lot of things that will be available to you. Yes. So Rahul, yes, there will be now if you go and do df dot shape, in fact, there will be more than your 13 columns. Okay. Let's move towards the other part is, I think earlier when we were doing this .info, we clearly saw that this borough and temperature also had some missing values, right? So before we go towards our EDA as well, it's important to do this missing value treatment. Okay. So what's the first thing which we can do is to check across the column. So this is just another way of checking that I have so many columns, and across each column, how many null values do I have? So I just did data frame dot is null, and then I just summed up across all the columns how many null values are there. So clearly it turns out borough has some 3000 rows as null, and temperature has around 359 rows missing. Okay. Now, whenever we are going to do missing value treatment for any data set, it depends upon the type, which means that if you are a categorical column, you will have separate style of doing missing treatment. If you are a numerical column, there will be another procedure for to do missing value treatment. Okay. So let's start with our first column, which is borough. So if I go and just do firstly a small analysis around the borough column, what I see is I have my 6 known categories which are equally distributed. I also did this drop NA equal to false. So by default, when you do a value counts, it will drop any NA value. NA means not a number, which is a missing value. So we already saw that 10% of your rows indeed have an NaN value. So usually what do we do? Whenever we have a categorical column, this thing, first of all, of entirely working with or filling the missing values, there's a special word to it. This is called as imputation. Okay. Now to do this kind of an imputation on a categorical kind of a column, it's little risky. Okay. So think of like this. It's more easy for me to estimate your age when I look at you as an individual than to estimate your name. You'll agree with me that if I just randomly come and stand in front of you, or you come and stand in front of me, it is slightly easier job. I'm not saying that it's easy even to compute your age. Okay. But if you ask me between the two, estimating or even guessing what your name could be is a far tougher task as compared to knowing your age, right? Why? Because probably some of your characteristics I can still quote a number from my past individuals that I might have looked. I can give you some kind of an average number around that. Okay. However, when I look at your person, you're a very individual kind of a person. Okay. So your name is very unique to you. So that's why what happens is when you are to treat these kind of missing values, particularly in the case of categorical columns, which is also called as imputation. Imputation is actually, first of all, applicable to both your categorical as well as numerical. So that's a technique. But what I want to say is that you'll agree with me that borough right now is nothing but a category. It's like a zone name, right? That, okay, when I was driving in Brooklyn kind of a zone, I had so many pickups. When I was driving in Manhattan kind of a pickup zone, there were so many kind of pickups. So When I have an NaN value, which means I don't know what is the zone name, slightly difficult task to predict what could be the right missing value treatment that I should do. So one of the safe things that we can do is I introduce a seventh category and say unknown. I don't know what your category belongs to. So I'll safely say that I don't know. And I introduce that using a function called as fill NA. So look at the way that I've done. What am I doing? I'm taking my column and then dot fill NA, the value which I want to pass. This in place equal to true is just going to ensure that whatever operation that I do of filling the value gets directly applicable to the DFPCA. So if I run this kind of data here, and now if you look at the Burrow distribution, I have, instead of making it as NaN, have made an additional category added called unknown, which is occupying some around 10% of this. And now if I currently look at the distribution of my null values, I don't find any null values in Burrow anymore. Okay. What can be some other ways of handling missing values? Yes, so that's a good point. The other way could have been that I take the most frequent value, which is the most frequent category in this case. Okay, so if any particular category would have been more present, that would have been the most easiest thing to do. Okay, I can probably look at that, if this particular category, or if this particular row is closer in terms of the other numeric values to some of the other regions, and then probably I could have said that they belong to a similar kind of zone. So, but some of the easiest things which I could have definitely done is the most frequent category would have become the easiest thing, right? Right now, I don't know, because you will see in my dilemma here, all of these categories are equally distributed. So there's no one single preference that I have in that case. Okay. Let's just give me 1 second. Hey, apologies, guys. Yeah. So in the other cases, what I could have done is I could have filled it with the most frequent category. Okay. So yeah. So what are the different types of null values, or is it NaN? Yeah, you can get NaN. This is most often you get it as NaN. Yeah. Okay. Cool. So now the other piece that we see is the temperature column, which is having the null value. So let's go and work with that. Let's just investigate that, what are the rows looking like wherever we have these temperature columns which are null. So what am I doing? I am only subsetting those rows where the temperature column is null. So if you look at it, right, pandas is more like an English language. I want to locate only those rows from my data frame wherein all those rows where my temperature column is null, just print it out. Okay. Yeah. So you'll see now I get this kind of a data set. Now focus very closely to the pickup date and the Burrow kind of a setup. Okay. So I'm already giving you hints here that firstly, what I notice that most of my values, it looks like they are all coming from Brooklyn, and it's all coming from maybe the month of January. Okay, in the first month of January. So you see 01, 01, 01. Yeah, it's all coming from the month of January, right? So this really, increases my curiosity. And I then go and say that, okay, wherever there was null rows, where the temperature was null, can you please take the Burrow column and do a frequency distribution? Oh, my hunch was correct. that indeed only there is missing values from the Brooklyn kind of borough. What about the start month? So start month again is 01. Okay. So here I am convinced that whatever the temperature column values which I have missing in them, they're all coming from Brooklyn for the month of January. Now you should ask yourself a question. Hardik, why I could have missed these values? Basically, what I'm saying is reason for missing value. See, of course, imputation is the treatment. Okay, I'm trying to understand that why on earth, firstly, there could have been a issue with respect to this. It could have been that there would have been an error. There could have been an error in my data collection activity. Something I might have done terribly wrong with my January kind of data join. It could have been that Uber itself would have not had data because of some system issues for the month of January for Brooklyn. Okay, so it's extremely important to know for a fact that why this issue has arisen. Okay, and knowing the source of missing value is also a part of our job before we go and do an imputation. Like, of course, in the previous case, I used an unknown value, but as I said, like, it's extremely important to go and investigate why do you have missing values. I think someone was also asking, like, can you tell me when to drop the null values and when to fill it? Think of like this: the intention is always to not drop. Okay, the intention is always to not drop. For example, uh, data is information for me, right? So I don't want to drop these values. However, think of yourself that what kind of a domain you come from, which means imagine you come from an e-commerce setup. In e-commerce setup, you have data in abundance. So even if you drop these kind of null values, it might not really make a difference in your setup. Okay. However, imagine you come from a pharma background or a medical background. Imagine you were collecting data for cancer patients. Okay. This is limited. Think of like this, guys. For this kind of a setup, or for you to even have one row for a person who had cancer, an individual had to have cancer. Okay, so someone has to have cancer for it to become a data point in your data set. You can imagine how expensive is this data set. So even dropping one rows is a very expensive exercise to do. So depending upon the use case and the domain that you come from, you have the leisure that if you can drop it, no brainer. But if you cannot drop it, then you can probably work with some of the imputation steps. Okay, cool. So here in this case, as a simple step, what I did, there are two options I could have done. I could have directly taken the mean value of my entire column and just filled that, okay, because it's a temperature kind of a setup. I know that in the New York City for the other pieces, wherever, it was Brooklyn or sorry, Bronx or Queens Island and all those things, in the month of January or overall, it would have not made much of difference. So this would have been like a very generic kind of a mean value. However, I know that, I missed out on only these Brooklyn kind of things. So what I can actually do is maybe not take the borough as Brooklyn, because that's where the piece is missing. Yeah. So here what I'm doing is I'm filling the mean value. The other piece which I could have done is I only go and fill the pieces where, I'm taking the mean for a particular, say, a particular region itself. So here I think I'm taking for month of Brooklyn, January. Actually, I should not take month of I should not take Brooklyn. I should only take for the month of January what should be my piece should be. Okay, so probably I can go and fill my temperature column with that value where, it's only taking the mean of January data set, not the overall data set. So from the overall column, instead of taking that where the start month was only January, from the other places I could have taken mean. So if I run this for now and just show it to you, now I have no mean value present. Now you might ask me, Hardik, okay, what are the other things you could have done? So here there are other pieces which you could have done from a central tendency perspective is you could have taken median value or you could have done a mean value. Mode is something that we use it only in the cases when it's categorical. Otherwise, we avoid using mode. Okay. So here it's like, just like how I have taken a mean, you could have also taken median value. Okay. So that's the thing, you can do it. Okay. Is that clear? You have to use copy the main data, otherwise you lost it permanently. What do you mean by that? I didn't understand that question, Sunanda. Are you saying that you should have taken the copy of this data frame and then do an analysis? Is that what you're trying to say? Yeah, I mean, you can do it. I mean, this is just a demo setup here, so it does not even, it's not very important. Like you can obviously go and load the data set again, so it's not that much of a difference. Okay. Max temperature is 89. It's not outliers, it's errors or fake data value. Yeah, yeah, correct. Yeah, true. Okay, moving ahead. Now, I think up to this point, this was just an example where, I showed you how we could clean the data. So a lot of hard work goes into cleaning the data sets. And now once we are done that, let's go towards what is called as the EDA analysis of what all things that we can do on top of that. So whenever we do EDA, right, basically we do this EDA in 3 steps. Okay. Step number 1 is what we call it as we perform univariate analysis. Univariate analysis. What does univariate means? See, variate means column, also called as features. Okay. Uni, one column, only one column. So which means what? I'm going to take one column, one column and analyze them. Analyze them. Try to interpret them. Try to interpret them. Okay. Once you're done with that, we go towards what is called as bivariate analysis. Bivariate analysis. So which means two columns at a time. Two columns at a time. This will help us to identify relationships in the data set. Relationships in the data set. Okay. And then we further go and do what is called as multivariate analysis. Multivariate analysis, which is usually more than 2 columns. So like something like 3, 4, depending upon your things. And that is identifying relationships for more than 2 columns at one go. Okay. Honestly, tougher task to do, easiest task to do, important task to do, tougher task to do. Okay, so not a lot of people end up doing multivariate. However, having said that, if you perform your uni and buy also very good, it will give you a lot of information still. Okay, so multivariate also you can stick up to 3 and 4, beyond which it might become a little complicated. So those are the things that you can end up definitely doing. So quick revision, where are we? We have this Uber data set. I did some kind of cleaning up to this point, and I also created some of the variables here. Now what I'm going to do, start looking at column by column. So let's start looking at first the pickups column itself. What am I doing here? I'm plotting the histogram of that column. Histogram of that column. Okay, maybe I can reduce it to 6. So if I ask you guys, I can even draw the box plot. So let me draw the box plot. Yeah. So what do you observe, guys? What do you observe from this histogram? So histogram is nothing but some kind of a frequency plot, right? So what do you think? What do you observe? If I have to write some observations here, let's see what people say. There are a lot of outliers present. So there are a lot of outliers present. Okay. What else? What else do you see? It's a skewed data set. Yes. So it's a skewed data set. Agreed. What else do you see? Any other things? do you see that there are a couple of modes which are present in my data? So there is one definite mode which is occurring around 0, and then there is a bump around which happens here as well, like around maybe 400 or 300, right? So it's a bimodal distribution, distribution, right? Bimodal model, right? Do you agree with me? Yeah, so these are some of the things. Bimodal means that I see there is one peaking here, and then there's another peaking here, and then there are these small dots which I see are definitely some kind of outliers which are present. Box plot is also capturing the same kind of emotion here. A lot of outliers which are present in my data set. Okay, what about visibility? Let's look at the same graph for visibilities as well. Any respite here or still very noisy kind of data set? Yeah, again, it looks like, I mean, histogram probably is not giving us a right information, but there is low visibility in some of the cases. Usually the visibility range is between what kind of values? Between maybe 9 to 10, right? So can you guess when do we have low visibility? So you are in New York, okay? For people who are aware, when do you think you will have low visibility? Any guesses? In winters, right? Like in fogs. Yeah, so New York is known for its very bad storms, the snowstorms that it gets, right? Like during these winter seasons. And we of course have data from January, so there could be the cases where, you know, there are these kind of values as well, right? Cool. What about temperature? Let's look at temperature. Temperature looks more often quite nicely distributed, right? So no problems here much. So I get, like, you know, kind of a nice curve I can draw on top of that. It looks like very neat performing, well behaved kind of a column in the midst of everyone, right? We can continue this exercise and then keep on looking at different pieces as well. So I'm looking at dew point right now. So here you see, again, more or less looks okay. Not much red flags in dew point as well. What about sea level pressure? Anyone has any question? I think someone has muted themselves. Vidur, I think you have muted yourself, unmuted yourself. Okay, thank you. Yeah. Yeah. What about sea level pressure? What do you think? Well behaved, not so well behaved? Do you see any kind of those black dots which you were seeing? Yeah. So basically, we understand box plot for people who are not aware. So this is what we call it as box plot. Okay, so box plot is nothing but, again, some kind of a distribution plot. It's a distribution plot. So in that cat example which I was showing, so it tries to tell you that what is the main area where the data is distributed. So I have this kind of a box setup done. And in the middle, I have this kind of a median value representation. I have the 25th percentile value representation. And then I have this 75th percentile value. Then I have this leg. Then I have this leg. And then I have this one guard value. And then I have this guard value. So these are called as whiskers. And then beyond this and above this is what we call it as our outliers. Okay, so in a way, it's giving you a complete overview of the column distribution. So in one shot, you know that how is the mean and the entire middle region behaving? How is your top values and bottom values behaving? A little bit extreme values. And then these are your outliers. Okay. This area comes by some analysis of how much is this area. Okay. So overall, when you look at this graph, we start to understand that is there any mischievous activity which is happening in the column. So currently looking at this guy or looking at this guy, it is not sounding so much and alarming as compared to what we had in this piece or in this piece. Okay, so that's the major idea. Also that we have inner outliers. So yeah, so we sometimes have, so these are basically what we call it as outliers. This is the upper guard, which is say some calculated value. Usually what we also have is in a more general setup of your box plots. So you have this one upper guard and lower guard. It's like if you're above this, you are some outliers. And then there is one more guard which is standing here. Okay, so you might call these as inner outliers and the pieces above them are major outliers. Okay, so it's like this is nothing but your 1.5 times interquartile range, so IQR, and this piece is 3 times the IQR. Above that is something which is horribly, horribly wrong. Okay, cool. I'll take a pause here maybe to check if all people are following, guys. I hope it's making sense to everyone, folks. Yeah. Okay, cool. So now I can go and do the same thing on the liquid precipitation as well. So I'm doing the same analysis on my liquid precipitation. So 1 hour precipitation, again, I see a lot of skewness in this thing, and 6 hour precipitation. And similarly, I can go and look at the 24-hour precipitation as well. So I am not looking at these graphs in greater details right now. The idea is, in the interest of time, that you get the point that the idea is to look at these histograms and these box plots column by column. Now you might say that, Hardik, what happens in the cases when we have a lot of columns? Very valid question. In that case, doing these kinds of histograms for a lot of columns becomes difficult. So we do some kind of a smart analysis in that case. We don't do it for all columns. We do it for, say, some of the important columns that I know which have come from the business domain that I carry. Okay, so at that point of time, your business domain will really become more important. That I have to pick, like, top, say, 10, 15 values itself. Someone has to inform you, either if you are not aware, or someone has to inform you. In that case, I can go and do the same thing for the snow depth as well. Okay, so I see a lot of outliers for snow depth as well, so giving me a good important information that there could be a chance that you have to do some kind of treatment for skewness in these cases. Okay, so up to this point, what we have discovered was only for numericals. We can now go and plot what is called as categorical plots, also called as count plots, for my categorical column. So I have these category columns, the holiday, which is just 2 categories. And I know for a fact that it's already something which it's not something that I'm not aware of, that 96% of my rows are belonging to the category N. 3.8% is only coming from my Y. So this is where I want to highlight one important information. See, it is so try to understand one thing. It is not always a compulsory step to go and draw a visualization chart. When a table information has given you that information which you needed, it could have been enough. Okay, so for this case, maybe a chart was not required. So I could have just, probably not drawn a chart here. Similarly, for boroughs, I already know what the distribution of my boroughs are. So probably this is not something which is giving me an additional information exactly here. Cool. I'll take a pause to check any questions around the univariate analysis before we go towards the bivariate. Yeah. Sure. Okay. Very quickly, I'll just summarize my bivariate, since I think we are inching closer towards the class. So as I was describing, bivariate means taking 2 variables at a time, right? So here what I'll do is I'll take two variables and I'll start to see some analysis between them, some relationship between them. One of the classic things to do when it comes, so you see that this kind of bivariate plots also, I can do it between numerical to numerical. I can do it between numerical and categorical. Okay. And I can even do, say, probably categorical to categorical as well. Okay. So let me show you the first example by plotting what is called as a correlation plot. Okay. So what is correlation plot? So correlation is nothing but some kind of an analysis. If I give you an example, that if your height is increasing and if your weight is also increasing. Okay. So this is like, you might have seen that if someone's height increases, the weight also increases. So what is this? It's like correlation, which means I'm trying to understand if there is any one-to-one relationship, mostly what kind of a relationship? Linear relationship between the two pieces, right? So height and weight, if they go hand in hand, which means if my height increases, my weight also increases, I can say that they are correlated with each other. What is another example? Say the example is demand. Yeah, probably I can write here price versus demand, right? Classic example, but now in the opposite direction, like this. So when the price is zero, the demand is at the peak. When the price is at the maximum, the demand is at the bottom, right? So what is this? This is negative correlation. So this is negative correlation. This is positive correlation. So understanding correlation is a good way to know what is the linear relationship possibility between the two features at a time. So here I can do that by taking these numerical variables. And then for this entire data set, I'm plotting what is called as my correlation data frame. Think of it as a value which is ranging between -1 to 1. +1 being more and more positively correlated, -1 being more and more negatively correlated. Okay. So here again, bunch of numbers to a naked eye, it might not really, it's something which is not really appealing. So what I do here, this is where visualization is very helpful. Okay. So if you go and draw what is called as a heat map, if I go and draw what is called as a heat map here, look at this, voila. Using beautiful colors and a proper heat map, I have conveyed you a lot of information. So let me explain you here. On the right hand side, you can see that I say that my correlation varies between -1 to 1, which is the range of the correlation. Here I have the x-axis and the y-axis, which is my two columns. And look at the diagonal. It is talking about the correlation value between the variable and itself. So therefore, correlation of the variable with its own self will always be 1. Then if I move to the next cell, it is the correlation of pickups with SPD. And if you just move one diagonal down to it, it is SPD with pickups. So you correlate X with Y or Y with X, which means you ask for correlation of height and weight and height, demand and price, or price and demand. The value is always going to be the same quantity. So you can probably look at the upper triangular piece here and look at the values which are above 0.3, both positive or negative. Okay. So look at this value. It says SPD with dew point. There's a -0.32, which means that the speed, if the speed increases, the wind speed increases, the dew point decreases. What about this one? Visibility. As the precipitation increases, the visibility decreases. Does it make sense? Probably, right? Because if it gets more and more rainy, right, there is a chance that there is a drop in the visibility as well. So they are correlated, but in a negative direction. What about this guy? Temperature increases. I forgot this SD. What was this SD? If someone remembers what was that SD? SD was snow depth. Yeah, sorry. Snow depth. Yeah, apologies. So does it make sense that if temperature is increasing, the snow depth is decreasing? Of course, if it gets more warmer and warmer, your snow depth is going to decrease, correct? So classic example of how you can see the relationship, mostly linear relationship between two features at a time. Look at this, highly correlated. So you can see temperature and dew point. It's 0.89 and it's very, very correlated with each other. Is correlation 1 possible for real world? No, there is no such thing as correlation equal to 1 for a real world kind of a data set. Okay. Now, after the correlation plot, I can go and start now picking up different things. So I'm now starting to pick up trends. Okay. So I'm now looking at trends here across the different timestamps. So the first thing which I'm going to plot is how has my pickups behaved across the months. Okay. So here what I'm going to do is I am plotting a line chart. Okay. And look at the line chart which I've drawn. So I have my start month and I have my pickups column. And then using this line chart, I am plotting the graph here. Okay. I think there's a question here. So why only float values, using float value? So correlation by default will be always a float value. It will never be an integer value. Therefore, I've plotted the float values. And this FMT, which you see here, is nothing but the float format, which I've said only restrict to 2 decimals. Otherwise, you would have seen I would have got 6 decimals. I've restricted to only 2 decimals. And this C map is nothing but the color map, which is showing you red, yellow, green. Otherwise, it would have been a default color. Correct. And this Vmin and Vmax is what I'm forcing that you show the coloring with respect to the range of -1 to 1 and annotation equal to true so that you see these numbers also on the chart. Okay. Now coming to this important chart, what do you observe, guys? So quickly iterating here, on the x-axis you have the month chart, and on the y-axis you have the sum of the pickups done for that month. So this is the first month, second month, third month, fourth month, fifth month, and sixth month. What do you think? So how do you read this kind of a chart? How do you read this kind of a chart? Yeah, so pickups have increased as the year has progressed, right? What do you think could be the reason for this? So any particular reason which you feel? So June has been the month where the pickups have been the maximum, and January was a month where, yeah, weather could have played an important role in this kind of a analysis. But the good point is that Uber over month on month is actually doing good with respect to its pickups. Cool. Let's do the same activity across the different month. Okay, so I have done this for the day of the month. Ignore these 2 last values because I think this is getting skewed because of February and the fact that a lot of months don't have 30 also value, so that's something which is dropping. So you see the last 3 values are quite bad. But what do you think if you look at from 1 to 28? What is the thing that you get to see here? Yeah, 20 got its peak at highest. For some reason, 20 is the highest. Actually, I should not show you sum. I should show you mean here. And similarly, I should also show probably the mean across the months. Yeah, this is the mean value. And this is also mean. So still, right? So this is it looks like as the month increases, there is an increase in the pickups in Uber's case, right? Ignore the last 3 values. Probably that might not be the right reflection because 30, 31st, and 29 might not be present in all the columns. But of course, there's a general trend which I see that as the month increases, there is more and more pickups which is happening across the different months. Okay, let's do the same thing across the start day. Okay, so here I have, I think this got repeated again. Yeah, so here I think the idea was to plot sum in the first case and the mean in the second case. So yeah, so we already spoke about this. If you look at it, the overall trend also from an overall month on month perspective, also this is increasing. And even on an average in the month, if I see on a day-to-day basis, basically this is day-to-day basis, this is still on an increasing trend. Okay. So I saw the monthly chart and I saw the daily chart. And now what I'll go and do, I'll look at the hourly chart also. So if I look at the hourly chart, okay, so hourly, it looks like this. So it is a little high around 12 o'clock in the night, and then it's decreasing till 5, and then peaks again, goes up to like maybe around 9 o'clock, and then slightly a little flatter, and then again peaks around 7 or 8 o'clock in the evening, right? So could make a lot of sense that it is the time where people probably here go to the office and return back from the office. So this is where it really makes a lot of difference here. Okay, so hour of the day is something also that's important. Okay, what is the trend across the different day of the week? Okay, so here across a different day of the week, what do you see? Sunday shows still some kind of attraction, but look at this one interesting thing, that Monday, Tuesday, Wednesday is something which is still smaller than Sunday. So that's an interesting insight that we are getting. Saturday is getting the highest traffic, followed by Friday and Thursday. So 3 days on the row, people have more pickups, falls flat on Sunday. But Monday, Tuesday, Wednesday is interestingly not as high as it should have been, more than Sunday at least. So that's a quite an observation here, right? Cool. So I think probably you guys are getting the point by these analysis which we're doing, right? Yeah. So this is just an example to show you how things could have been done. We could have also drawn these kind of charts across different boroughs as well. So for example, now let me go and show you that if I go and draw, so here what I'm going to do is I am taking the different variables and I'm plotting the different bar plots, or basically the box plots, in just one go. So here the idea is to go and check if there is any outlier treatment required. So the point which I'm trying to drive here is that whatever single variate analysis that we had done above, we could have also drawn like multiple charts in one go for different what do you say, variables, and we could have drawn like a box plot in this setup as well. Okay, so that's just also something that we could have done. I think there was one more chart which would have been present. Just give me a second, guys. Okay, let me share my screen again. So yeah, like we see that uh, we have this kind of a plot done. Now you could have repeated the same exercise for across more variables as well. So things like what you could have done is uh, taken the different box plot across your different boroughs. So for example, if I would have to plot the entire pickup in one single go, I think I had that chart, but somehow I think I've lost it. So the idea was that in my y-axis, I will have my pickups, and in my x-axis, I'll have my borough. So let's see if this plots here. Let me see if could not interpret borough. maybe I need to pass my data column also. So data column equals to df. Let's see if this plots. I hope it should plot. Yeah, so the idea is you can see that, I am drawing a similar kind of a distribution across the pickups for different boroughs. So this is also an example of now multivariate. Okay, so this is an example of multivariate chart. Why multivariate? Because this is also an example of bivariate only, sorry. So across the different boroughs, I have the here pickups done. So this is actually an example of numerical with categorical column. Okay, so in the above pieces, we saw numerical to numerical. Here again, we are looking at numerical only. And here we have looked at a numerical with categorical. Okay, so this is another example of a bivariate plot that we see. Okay, I think we'll stop here. The ultimate insights, something that you could have given is, so what are things that you could have taken from an insight perspective? So let me see, what are certain things that we see from our graphs now? So one thing is for sure from this graph, that Uber is very popular in Manhattan, right? So very popular in Manhattan, right? What else do we see? Yeah, so the rides are are on the high side during 8 to 10 a.m. and then again it peaks up after 7 p.m. correct? So it does not do well during winter, correct? So not so great during winter. And overall the trend has been on the increasing side. So a trend increasing from Jan to June, right? What else? On Saturday the rides is high. Yeah, so Saturdays the rides are high. Saturdays rides are high. You can in fact, even plot across the different boroughs and across the day of the week, what is the distribution. So that would have been the three level plot here, right? So Saturdays the rides are high. What else? Outliers were high due to null values, correct? So what else do you see? Brooklyn has outliers. Yeah, Brooklyn has outliers. So I think this is majorly some of these pieces which you definitely have insights. You can convert these insights into some kind of a recommendations also for your management, so that they can start to look at maybe more better service in Manhattan, can even introduce more price dynamics in Manhattan. May not be the best thing to do in EWR. So if they want to really capture this kind of a market, could probably give more discounting here, have more and more rights installed during this type of time, so that you don't lose out on the core business that you have. Okay, cool. I think I'll stop here right now. Anyone has any questions before we conclude? So I hope guys, via this small analysis, you at least got a flavor of how things have worked here. Okay, so of course I understand that probably time must have not been our friend here, but I hope I'm able to instill that what is the right kind of an analysis, and what by doing this kind of an analysis any company can benefit in the end. Outliers, think of like this right now as people who can disturb the normal distribution. They are people who don't follow the regular trend. So for example, if I ask what is the normal age of people, you would say that it's between, say, something like 0 to 100. But then if someone comes and says that my age is minus 56, right? That's not a regular pattern which the person is following, right? So that's an outlier. You can think of like this. Cool, I guess.
All right, Hardik, thank you so much for such exemplary wisdom. So I hope everyone enjoyed such a great session from Hardik. And it was indeed such a very lucid, I would say, flow of things. So I hope everyone was able to catch on to the core concepts of exploratory data analysis. So I'll just take guys 5 minutes to give you an idea about what are we trying to do at AlmaBetter. So I'll just go ahead and share my screen. And all right. So I hope you are now able to see my screen. Just, yeah, excuse me. All right. So, so the guys who are joining in this session for the first time and people who have already enrolled with us, so please ignore. But we are more or less a community first learning platform where students can study in groups, right? So they are learning in groups and getting motivated from their peers. They are doing projects in teams because that forms an essential part of their practical learning. And they get ready for jobs via networking with our expert coaches and industry professionals, right? So people like Hardik, they are coaches with us, and they have been really helpful in imparting true learning to our students, right? So this is what we are at AlmaBetter, and it's a very straightforward process, right? So you come and sign up and enroll with us, right? There is a refundable enrollment fee. You complete your learning journey, you get certified, then you sign the ISA, and then you get your course fee refunded, and you start your placement preparation in AlmaX, and then eventually we share your profiles with our hiring partners, and you land your dream job, right? So in AlmaX, we are going to work on your portfolio. So be it your resume, be it your get off portfolio or medium, or your own personal website, or even your YouTube channel, right? So we'll work on curating your portfolio and how you should be portraying your projects there. What are the core skills that you should be mentioning? And then we conduct a lot of mock interviews, around 40 to 50 mock interviews for our students. So that helps them basically revise and prep and put them in a real life scenario, like how they're going to face in the real interviews, right? So once we have assessed the student that now they're more or less ready to do the interviews, we share their profile with our hiring partners, and eventually in one or two, in fact three interviews, they get the job, right? So that is more or less the path to success that we are providing, right? And just trying to focus on the learning activities and the pedagogy that we follow. So for technical skills, we have live lectures, lab experiments, you have your coding playgrounds, you have a lot of interesting projects and assignments, and a lot of group discussions, right? This is to hone in your technical skills. And then for motivation in the industry exposure, you can connect with your mentors on one-on-one basis. And then we'll keep doing master classes like these so that you get that relevant exposure, right? And you also so because community is at the core of our platform, right? So there's a lot of community participation which is going on, and you can too be part of it, right? And then of course for Almax, there's certain things which are mandatory, which are essentially your milestones in the learning program. So you need to complete certain capstone projects at the end of each module, and then and few competency challenges along the way, right? So these are our learning activities. We have more than 500 companies hiring from us throughout the year, right? So you can see some big names here like Cred, Swiggy, Uber, right? So folks from these from our community have been hired in companies like these. So and we are and we'll keep on collaborating with more than in fact 1,000 companies in this year overall, right? So and these are some of the success stories. Of course, you can visit our website, and of course, you can look at these success stories on our YouTube channel as well. So just, yeah, keep sending your love. So all right. So this is what I wanted to just more or less share. And there was one other thing. So just wanted to give you a tour of your platform, as in how what will be accessible to you. So you can simply go ahead and sign in, right? And you will come to this something called Grow, right? And this is your goal. So of course, I'm assuming you are pursuing data science, right? So you have your home, learn. So every learning resources will be here. So let's say this is your main program page, your course page. So let's say I can go ahead to introduction to strings, and there is this video, right? I can hop on to activities from here, right? So this is the read collab, this is the read activity. So initial learning activities, and then you have assessment activities like coding assessment, and these are something that we have built, right? So you can simply start writing your code, and see for yourself if you're able to do them or not, right? So of course you can use Google Colab and use our editor as well, and there are a lot of settings that you can do. So you can do let's say uninterrupted coding, right? And you have a lot of controls here, right, as a student. So now you can just go ahead and take the quiz here. There's a discussion forum associated with each and every lesson, and you can also, let's say, go through the video while you are attempting other activities, just in case you wanted to go through them again, right? And you can submit a feedback as well. So this is more or less the curriculum, right? And then you have a lot of problems to practice, right? So let's say this is like divide the numbers. You can go ahead and start running your code and keep experimenting with them, right? So you can now run your code. You can see your submissions as well here. You can see the hints too, and so this is curated for you to practice a lot of problems. So these are in Python, SQL, and mostly those, right? Because these are the two main languages or frameworks that we are following within the data science program. But we do also have support for JavaScript, React, and HTML, CSS as well, right? So these are like coding assessments. You can go through a lot of quiz assessments, and you can see your completed assessments here, and a lot of interesting projects, right? So you can go ahead and see this clustering project on Netflix, for example, and there are the details of the project, right? So if you have any feedback about these projects, please do let us know, and so that we can improve our material and content, right? And here is your AlmaX tracker, and you can see what are the milestones you have completed so far. So this is to keep track where you are in your journey, and then you can simply go ahead and book your mentor session, right? So let's say you want to book a session with Hardik, so probably you can go ahead and book a guidance session, and probably let's say if Hardik let's say gets to know about that session, he can go ahead and accept those, right? And of course there's a help desk forum. This is where our knowledge base is there, so you have any query, you can go through those, and there's a discussion forum for each of the modules and lessons. So these are places where the community is discussing about the technical content and material. So it's a best place to be. It's a really good place to be around, right? And then of course there's this community bit. Cannot highlight less about it, right? So here, let's say this is pretty much like Facebook or LinkedIn, but you have a lot of groups and spaces. So let's say you are studying all day and you want to have some fun time, so you can go through these memes or maybe share your own, right? And you can also discover a lot of people from your network. So let's say I am from, let's say, Patna, right? And I want to identify people in the network who are from Patna, so I can do that, and you can do that from anywhere, right? So this is a good way to network with people, and overall that's there. And there are a lot of things that you can see on the dashboard, like you can see what are the ongoing cohorts. So let's say if you fell sick for a certain part of the phase, right? Or maybe you lagged behind due to your other time commitments. So here you can of course track your own cohorts, but we are also giving a flexibility to switch your cohort to, let's say, a later cohort or a future cohort, and so that you can resume your learning more or less, right? So these are like very student-centric features that we have developed as part of the program. So please, I think you guys can use it if the need arises, right? So more or less that, and of course you can refer your friends from our platform. You can just share this link with them, and you get 1,500 rupees, and your friends get the same, right? And there is a performance tracker that you can track, right, as in to gauge your progress across the module. So you can just jump across modules and see your progress and your attendance, your daily quiz, your capstone project, right? So a lot of things we have built in the dashboard, so for your convenience, right? So this is more or less what I wanted to share with you guys. So if so we can take, I think, a few questions for 5 minutes, and then we can wrap up this masterclass, I guess, if there is any. So sir, please tell how to improve Python. Hardik, do you want to take that question?
See, learning Python is just like learning any language, right? Today, if I try to teach you Russian, it will take you some kind of time, correct? So I think learning Python is a not a deal breaker kind of a setup. You can pick it up, say maybe like 3 weeks of time. Again, like in the end, try to understand this thing. We want to learn Python as much as so that we can solve the DS problem. We don't want to become a Python developer in the end, right? So whatever I think we can do it, like it should take like around 2 to 3 weeks of time to really get started working with Python.
All right. So any other question? So where can I see this recording in Alma dashboard? So just, guys, I'll just share my screen and let you know. So so overall, right. So you can simply go to our YouTube channel, right? And here under live category, you will be able to see the recording of this session, right? So which is currently live, right? So we are streaming it live on YouTube. So it will be available there as well, right? So let's not worry about that. Yeah. Right. So cool. Um, all right, I think we can wrap up this session. So Hardik, thank you so much again for this wonderful session, and I hope everyone benefited from this. I know it's past 3, but I think the more the merrier. So thank you again, guys, for attending the session. In fact, taking such a long time out of your hectic schedule. So really, thank you so much. All right, guys. So we'll close the session. We'll see you guys again
Yeah.
in all these master classes.
Thank you so much, guys. Thank you. Hoping to see you more in AlmaBetter.
Definitely, right? So we'll plan to do more of these. I think going ahead, and we'll keep doing these. I think. All right.
Thank
All
you.
right, guys. So you'll get the certificates over the email. So I think just check your inbox after a certain time. So cool. All right, guys. Okay, thank you so much. Okay, bye.
Bye, everyone.